Hey guys, welcome back to AlgoYogi. We are doing linked list series. Our next problem in the list. This is the first medium level problem in the linked list series. So problems will be a little challenging. So next problem is merge in between linked lists. So let's go to LeetCode. So you are given two linked lists, list 1 and list 2 of size n and m respectively. Remove list 1's nodes from ath node to the bth node and put list 2 in their place. So the blue edges and the nodes in the following figure indicate the result. Okay, so they have shown this really beautiful diagram here, this picture, and we can clearly understand what they have actually done it and what they are actually asking us to do. So this is the ath node, and this is the bth node. So what we do, we get rid of this particular section and we place in this particular linked list in there. So although they have shown it so beautifully using the pointers, how it would be just like a piece of cake if you just, before the ath pointer, you point its next to list 2's head, and then you traverse list 2 and points its end tail's next pointer to the to the node in list 1. That's the next node of bth node. So there are a couple of ways of doing it. First would be, how about we take all of these nodes and we could just store them maybe into an array, and then we traverse onto the nodes using whichever node is at ath index, which will be an integer. We point its next to the list 1's head, and we traverse list 2 again and then points it to the bth indexed node. And remember, these are already like very well created lists, so it's just all about changing the pointers, and we are storing the nodes just for the sake of our reference, so that we can refer the node using its index in list 1 and just point the next pointer to the list 2, and from list 2 to list 1 bth index. So that will take big of time complexity, will be big of m plus n. M is the node in list 1, n is the node in list 2, and space complexity would be big of m. So can we do better? Answer is yes. Yes, we can do better. How about, instead of storing these nodes, how about we just play with the pointers? And that's what we have been doing with a lot of these problems recently. So what we are going to do is, how about we traverse list 1, keeping in mind that we want to stop at the index 1 before the ath node, right? So when I'm traversing list 1, I stop right here, and I'll show you how we do it in the code. And from there, I point my next pointer to list 2, then I traverse this list, and I stop one node before my none node in the list 2, and I point this node. But remember, I will also have to traverse this first, and stop at one node after the bth node. All right, it could be null, it could be anything, but that's not our issue. We want to take care of all the cases. So then here, instead of pointing my next to none here, what I will do, I will point my next pointer to b plus 1th node. All right, that is our entire solution. This is where I was playing, but there is a better picture over here because I got just so busy, not so busy, just I was into this and I was just solving it in my head. But anyway, let's write the solution, and this will not require any space at all, just 2 pointers playing around, more loops but less space. All right, let's write our code. So first thing first, what I'm going to do, and this time I want to have this side by side so that like while I'm coding I can refer to this picture. So what I will do is I want to reach to eighth node, but I want to keep track of one before it. So I'll say eighth node would be a node, which will be pointing to list 1. I just don't want to list, I don't want to use list 1 because I will need its reference because that's what I will be returning in the end. So a node, and I want to have a pointer 0 and then looping in to reach a minus 1. So while ai is less than a minus 1, that's where I want to reach, and until then I will just keep doing a node equals to a node dot next. All right, once I come out of here, I should have called it a minus 1, so I'll just call it a at. No, I'm just going to keep it a. But remember, it's a minus 1th node, right? It's not the ath node because we're not including that. So that's our node. Now I want to go to bth node. That I will try, basically, let's call it maybe head, and I'm gonna call it a minus 1, not minus 1 node. And then what I want to do, so I reached at, let's say I reached at 13th. 13th is my ath node, but I want to make a reference of it, so I'm calling it head, and then I'm going to start. I'm going to keep iterating basically. I forgot to increment ith pointer, but while I is less than equal to b, so that I am basically going over b. My ith surpasses until it's equal to b. It's going to keep incrementing and it's going to stop when it becomes greater than b. All right, until then what I'm going to do is I'm going to keep incrementing my ith minus or you know what, I could have called it b node. That will make it easy. So b node equals to b node dot next, and I will again increment my I pointer. So so now I have my a node reference a minus 1, and then I have my b node reference when b is basically 5 and it's 13 in this example. Then I have these two nodes. Now what I'll do is point my a node dot next to list 2. That's it. I have just pointed my a dot next to list 2. I will now traverse over while a node dot next until that value, basically until I have not reached the last element, not the none, just the last element in list 2, which is like this 0 0 whatever this value is and 2. So that's where I want to reach while I'm at the last node. So I'm going to keep incrementing it. So a node dot next. I've already used this a node, so I'm going to keep, it doesn't matter. So a node equals to node dot next, and then once there will be a point where it becomes basically next is not there but current value exists. That's where I have reached the end of my list 2, and I want to point a node dot next, which is none right now. It will point to bth node. So b node, that's where it's pointing, and that's it. And if everything that we have done is correct, if I return list 1, which I'm very hopeful that it should work. Okay, so let's again go over. I have a node as list 1, I have the index 0, I'm iterating over my list 1 until I reach ath minus 1 node. That's where otherwise I'm keep incrementing it. My ath node remains that, but I assign my bth node ath, and right from there I start iterating until I reach basically b plus 1th node. So b plus 1th node, and this is where it will keep incrementing. And then I want to take my ath node back and assign its next pointer to list 2, and then I am checking, I'm basically traversing to the end of list 2 and stopping at the last node, last valid node, and then after that I'm assigning ath dot next to b node, which is b plus 1 node, and then I'm returning this one. All right, so let's run it. God, please fast. I really don't want to see anything over here. Yeah, but that's okay. These are these typos could happen, but I don't want to see anything bad in the logic. All right, passing the test cases. Let's submit. Awesome. I don't care about the efficiency here. Space is optimized, and let's write down the time complexity, which is time complexity basically big M plus N. And you know why M plus N? Because we're traversing both the list. And space complexity would be big of 1. That's what we reduced when we gave up on this stack or the array approach, where we were storing the elements of list 1 and then taking those ath and b plus 1, a minus 1th indexed, and just pointing them to list 2. Here and up, here and up. All right, let's go to AlgoYogi, mark this solved, and see you guys in the next problem. Bye-bye.